Hello, and welcome to our presentation on WPA cracking. Understanding the potential security risk associated with WPA is crucial for individuals and organizations. This presentation aims to shed a light on the vulnerabilities inherent in WPA, exploring its risks to the security and integrity of sensitive information. We will be discussing what impact WPA cracking can have on individuals who are on a secure home network to organizations who have sensitive information stored. We will also be exploring on how the WPA works on safeguarding us from potential threats. Let us discuss some of the potential risks that WPA cracking exposes us to. Data interception. This can let the attacker take and see the victim's data that is being transferred between devices by using a four-way handshake. First, the IDs of the two devices that are receiving and sending the data. Second, the two cryptographic numbers that is used to communicate with each other. These are the things that the attacker needs to form a four-way handshake. Privacy invasion. The attacker can listen to conversations between the machines transmitting data. They can expose the personal information of the victim or sensitive information of the company and be able to hold it for ransom. Man in the middle, being able to alter the data that is transmitted once the attacker has exploited the WPA weakness and has gained access to the victim's network. Let's talk about who and what it impacts. A WPA cracking affects any device that is connected to the Wi-Fi. This happens by the attacker exploiting the WPA weakness by targeting the security protocols that are set in place. The victim of WPA attacks can be a single person or a whole organization. WPA attacks can cause serious harm to whoever may be a victim of this attack. Their sensitive and personal data can be exposed at any time and be seen by the attacker. Their privacy is gone due to the attacker being able to track, grasp, and expose any kind of data that the device is sending or receiving. There is also the damage to the person's personal life that they would have to deal with after a WPA attack. If the attack were to happen to an organization, their reputation is damaged, their information could be held ransom as stated as the previous slide, or worst comes to worst can cause bankruptcy.
So what is WPA? WPA is Wi-Fi protected access that has three different versions to it. It was originally created to help secure networks and address weaknesses in WEP. It's created to help secure wireless networks and protect all users' wireless transmissions. There are some major key features that we use in WPA. First of all, we use a much stronger encryption than WEP. The most common one used was TKIP, also known as a Temporal Key Integrity Protocol for WPA. For authentication, we use something called CCMP, which stands for Counter Mode with Cipher Block Chaining Message Authentication Code Protocol, Key Exchange. This protocol assists with validating, basically to prove who you are, and you can access the information that you're supposed to access. Next, we have the key management, which uses a system called pre-shared key, also known as PSK. This improves on the key generation process during authentication. This helps prevent the use of static keys or easily guessable keys, which could lead to vulnerabilities in the system. And last but not least, there are several integrity checks that include mechanisms to check the integrity of the transmitted data, helping to ensure that it has not been tampered with during transmission. WPA1 was introduced in 2003. It was a solution to address vulnerabilities in the WEP protocol, also known as the Wire Equivalent Privacy Protocol. It included improvements to its encryption and key management compared to its successor. Now let's look at WPA2, which was introduced in 2004. Since WPA1 was a Rust job, it had a lot of things missing from it. So WPA was introduced to improve upon those security measures. The main improvement was that it used the AES encryption, also known as Advanced Encryption Standard, which basically provided more robust and secure solutions to securing your wireless networks. And last we have WPA3, which was introduced in 2018. This was introduced to address different security issues we are now facing in the world, considering the old protocol came out back in 2004. Its main features were to add protection to IoT devices and improve the AES encryption to provide stronger security to your information being transmitted. And last but not least, we are going to take you through a demo of cracking WPA.
This is a demonstration on cracking WPA/WPA2 Wi-Fi routers using AirCrack-NG. So some requirements before we start: you're going to want to run Linux. I would be running Kali Linux. I would recommend that. It comes with AirCrack-NG already installed, as well as some other tools that are useful in general for penetration testing. You're also going to need a wireless card that supports monitor mode. Not all wireless cards do, so in this instance I've had to acquire a USB wireless adapter that supports monitor mode. Of course, this is just a demonstration for penetration testing purposes, for educational purposes. You should not be doing anything you see in this video on a network that you are not in fully control of. Once you have all the requirements ready, we're going to want to check to make sure that our interface actually has compatibility with monitor mode. And we can do that by running the airmon-ng command. And that's going to show us all the interfaces that we have that actually have monitor mode functionality. So in my case, the interface is WLAN 0. It's a TP-Link TL-WN722N, which is a wireless USB adapter. And it does support monitor mode, which is why it shows up in this command. If your card does not support monitor mode, it won't show up here. So that's how you know whether or not you're okay to continue. Once we know what our interface is that we want to enable monitor mode on, we can enable monitor mode by using the command airmon-ng start and then the interface name. So in my case, it's WLAN 0. It may be different in your case. So we can start it. We can ignore this, or at least I can ignore this little warning here where it wants us to run airmon-ng check kill. I found that when I run this command, it kills this WPA supplicant, and the next step is not actually going to work properly if we do that. So I'm going to go ahead and ignore it. You may need to run it in your case, though. Once your card is in monitor mode, we need to find a target to crack. So what we're going to do is use that monitor mode to listen for beacon frames that are being broadcast by wireless routers that are close to us. Beacon frames are broadcast by wireless routers to give other wireless devices information on how they would connect to the device. So for example, they include things like BSSID, the channel that the router is running on, and some other information that can be used to connect to that device. Okay, so in order to capture those beacon frames, we're going to run a command that comes with AirCrack-NG. It's called aerodump-ng, and then we're going to input our wireless interface. And as you can see, we get several different beacon frames that we've captured. I'm going to just end that there because we have what we need. So the information that we're going to need from the beacon frame that we've captured is the BSSID here. So it's this line that we're looking at. We need the BSSID, and we also need the channel. So what we're going to do next is try and capture a four-way handshake, which is going to help us to crack the password for the network. So in order to capture this four-way handshake, we're going to run another command here. It's going to be aerodump-ng -C or -C. We're going to specify the channel that we're on, which is going to be 4. Next, we're going to do --BSS ID, and then we're going to just copy and paste the BSS ID from up here and paste it there. Next, we're going to specify just a file name, which is for the packet capture that we're going to do. So I'm going to call this demo, and then we're going to specify the interface name. So right now we're waiting for a four-way handshake to come through, which is essentially going to happen anytime a device connects to the network. So instead of waiting passively for a four-way handshake packet to be captured, we're going to run an active attack called a deauth attack, where we inject the authentication packets into the target network in hopes of deauthenticating or disconnecting a device or devices from the wireless network, at which point they will be either automatically reconnected and we can capture a four-way handshake, or they will be manually reconnected by a user and we can also capture a four-way handshake. So while this is running, we're going to open up a new terminal. We're going to enter root, and then we're going to run the command air replay -ng. We're going to specify -0 and put 2 here. That's the number of deauthentication packets we want to inject into the network. And then we're going to specify -a and the BSS ID of the network that we're trying to attack. Then finally, we put in the interface that we're using. So we've sent the deauthentication packets out, and if we switch back over to our monitor here, we can see that we have in fact captured a WPA handshake. And this is going to output a file for us that we can now use and crack the password for this network. Okay, so what we're going to do now that we have the four-way handshake is run a dictionary attack against the captured packet and see if we can crack the password that way. In order to do this, let's first check the files that we have here. I'm just running this in the root directory, but this file here, this demo1.cap, is the file that we want to look at. If you remember a few steps ago, we specified the file name as demo, and it just appends this number based on the number of times you've run it with this file name. And the .cap file is the captured packet that we want, that four-way handshake. So in order to run the dictionary attack, we have an aircrack-ng command. We're going to specify A2 here. A2 specifies that it's WPA2. You would just have to check that on the beacon frames that we were capturing earlier if it was WPA or WPA2. -B is going to be the BSS ID. We should still have this pasted. Give me 1 second here. We need this we need this BSS ID, so we're going to copy this here. Go back. Paste the BSS ID. And then W is specifying the word list that we have. So this is just a text file. I'm using this right here, dict.txt. You can use any dictionary word list that you want. You can find them online if you're looking for ones that have the most common passwords. But dict.txt is going to be good enough for our purposes here. And then finally, you need the cat file. So ours is demo-01.cap. And then we run it here. And you can see pretty quickly it found the key for the network. That's this here. The password for the wireless network is password. So now that we've connected to the network with the password that we've discovered. I'm just going to do a quick showcase of some of the impact that that might have in a real world scenario. So of course, network access is pretty important for doing reconnaissance if you were in the shoes of an attacker here. So I've connected to the network, and I'm just going to pull up Wireshark here. We'll select our WLAN 0 interface. That is the Wi-Fi adapter that we're using. As you can see, we've begun capturing packets for devices on the network here. It looks like these might be from the router itself, but if there were other devices on the network, we could start capturing traffic from them. And there's a lot of different directions that an attacker might go from there. You could start enumerating services that are um, on the network. You may be able to capture sensitive information in transit as well. The possibilities, they're pretty varied once you actually have access to the target network. So that was a demonstration of WPA cracking. Thank you for watching.
And these are our sources, and thank you so much for watching.